Okay class, tadi kita dah solve example 5. Now we have example 5.1. Example 5.1 ni kalau tengok, kenapa dia jadi 5.1 ni? Okay, if you look at the question, it still solve the same thing. Okay, still solve the same thing. Dan sebenarnya kalau dalam example 5 ni, okay, example 5 sebelum ni, okay, we have utilized the initial condition given u0 t equals to 0 and the boundary condition ult equals to 0, but we haven't talked about this yet. Betul? U at 0 fx. Bila nak guna benda ni is here in example 5.1 we have u at 0 equals to fx. Okay, where soalan ni cakap, okay, example 5.1 solve blah 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 for the given initial condition. For the given initial condition here, u at 0 ni equals to fx. What is 0 here? T is equals to 0 here. Okay, t is equals to 0 here. So maknanya kat sini kita punya condition u at 0 kita adalah equals to, untuk A, for A, our u at 0 is equal to sin 6 sin n tak ada n pun, sin pi x over L. Before this, in example 5, we already have the solution, right? Our general solution, u at t equals to bn, apa dia? Bn sin n pi over L, n pi x over L, e the power of minus k, kan, n pi over L square t. Betul? This is a solution that we get from example 5. Okay, sekarang ni what is given to us, u at 0 is equals to this one. Maknanya for this case, t is equals to 0. Bila, okay, kalau you tengok kat sini, kalau yang this case, u at 0, bila t equals to 0 kat sini, this term will be 0. Betul? Okay, then we have bn is equals to sin n pi L, n pi x over L. So maknanya yang u at 0 dengan u at 0 yang ni adalah sama. 6 sin pi x over L. So by comparing like this, maksudnya automatically kita dah tahu what is our constant bn. Our bn is equals to 6. Betul? Our bn is equals to 6, and for this case pi x is equal to L. So kalau you compare, pi x over L is equals to n pi x over L. So it gives us our n for this case is equals to 1. Faham? Okay, bn is equals to 6 and n equals to 1. So maksudnya kita punya u at t untuk soalan A ni adalah, okay, our u at t for A, dia punya general formula kan yang ni, bn sin n pi x over L e the power of minus k n pi L square t. So our bn is equals to 6. Okay, bn equals to 6, sin n is equals to 1, so sin pi x over L e the power of minus k pi over L square t. Okay, tu adalah kita punya solution. Okay, for the PDE where the initial condition given to us fx equal to sin 6 and pi x over L. So this is the answer. Okay, if given our initial condition fx equals to 6 sin pi x over L, where u at t equals to 6 sin pi x over L e the power of minus k pi over L square t. Alright, so now tengok yang B pula. Okay, so for B, kalau you tengok B ni pun, fx ni sebenarnya adalah ux0. Okay, u at 0. So u at 0 is equals to 12 sine n pi x over L minus with 7 sine 4 pi x over L. And we know that our u x t, okay, u x t is equals to bn sine n pi x over L e power of minus k, okay, pi or k pi over L, k pi over L n pi over L square t kan, n k pi over L square t. Alright. Okay, so kat sini kalau you tengok kita ada dua. Okay, we have two terms. Okay, we have two terms for our u x 0. Compare that tadi, we just have only one term. And again, you hear u at 0 indicates that t is equals to 0. Indicates that t equals to 0. Maknanya the exponential part gone become 1 kan. Alright, so daripada sini there are two terms. So maksudnya kat sini ni I want to recall back the solution. Remember the solution for the differential equation or ODE is equals to, kejap ya, okay, we come back to our earlier slides, okay, in the first part of the video yang sebelum ni, where it's saying that it follow the fundamental theorem of superpositions. Maknanya u, the solution for the PDE can be, okay, u equals to C1 U1 plus C2 U2, meaning that the first solution plus with the second solution. Okay, maknanya dia bukan kata ada only one solution. It can be an addition of few solutions, okay, or few series of solution. Okay, alright, so daripada situlah, okay, daripada situlah kita tahu sebenarnya this one is one solution and this one is the second solution. So maknanya dia adalah B n ni, they are n can be n equals to 1, 2, 3, 4 and so on. So now you have to find out yang ni n yang mana, yang ni n equals to berapa. Sebab kalau tengok pattern lebih kurang sama, cuma what varies is yang kat depan ni, yang ni 12, yang ni 7, and then yang ni pula 4, yang ni adalah 9. Okay, so you may compare. Okay, you may compare. So maknanya kat sini kita ada 12 sin 9 pi over L x equals to bn sin n pi over L x. So daripada sini kita nampak kita punya bn for the first term is equals to 12 and n kita, okay, by compare macam ni je lah, n kita sama dengan 9. Whereas yang second ni pula kita punya bn kita sama dengan, you can say 7 or minus 7, and our n is equals to 4, betul. So maknanya this is b4, okay, because n is equals to 4 and this one is b9. b9 is equals to 12 and n is equals to 7. So makna kata dia punya solution ni, that's why dia keluar macam ni. Okay, 12 because this is our b9. b12 sin n pi x over L. Dan kita tambahlah ini sebab this is u x t kan. So e the power of minus k9. Okay, 9 kat sini because n pi over L. N pi over L square. So 9 pi over L square t. Minus with 7, this is minus 7 is our second bn, sin 4 pi x over L. So our n here is equals to 4. So that's why inside here we have 4 pi over L because this one n kita sama dengan 4. So that's why the solution for B is equals to this one. So maknanya dia yang B ni kita ada C1 U1 plus with C2 U2 ataupun B1 B9, okay, sin blah blah plus with B4. Itulah maknanya kita ada more than one term for our solution for B. Okay, so hopefully all of you clear about this. Okay, rentetan daripada situ, okay, rentetan daripada situ, kita tahu our solution tadi, general solution untuk kita punya same question macam tadi, still lagi same example, since example 3 tadi, our solution is equals to this, kan? Bn equals to sin m pi x over L e the power of minus k m pi over L square t. Okay. However, okay, kita boleh tulis kita punya solution dalam bentuk summation macam ni. Okay, kita boleh tulis kita punya solution dalam bentuk summation macam ni sebab, okay, sebab apa? Sebab contohnya daripada example yang ni tadi, kita tahu the solution can be more than one solution. Okay, it will be macam ni, dia ada dua, but there's a possibility dia akan jadi 3, 4 and so on. So in that case, it is sum up dalam bentuk summation macam ni. We have, okay, summation from n equals to 1 up to m bn sin m pi x over L e the power of minus k m pi over L square t, with the condition that u at 0 kita sama dengan yang ni. Okay, u at 0 kita sama dengan the first part ni. Okay, because kalau t sama dengan kosong kan, yang ni tak ada. Okay, so u at 0 kita sama dengan yang ni. So as m approaching infinity, so kita akan dapat ust kita summation n equals to 1 up to infinity, bn blah 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 equals to this with this. Does this look familiar to all of you? Okay, nampak tak? Yang ni kan biasa macam pernah nampak kan? Summation of from n equals to infinity bn sin m pi x over L ni, this is what we call as Fourier sine series, kan? Sin m pi x over L, remember? Okay, we have discussed this in chapter 4, okay, where our fx equals to this one. So to determine the bn, okay, what is bn? Alright. So you should take note kat sini dululah for untuk ni. Okay, the Fourier sine series of fx will be continuous and converge to fx from 0 to L provided fx is continuous. And okay, untuk cari bn ni, you boleh follow the same formula as in chapter 4, where you can straight away simplify the formula from equals to 2 over L integration from 0 to L fx sin m pi x over L dx, irrespective of whatever function of fx pun tak apa, tapi you have to make sure it satisfy the condition f0 equals to 0 and fl is equals to 0. Macam soalan ni, kita dah check sebelum ni kan, v0 is equals to 0 and vl is equals to 0. So it satisfy the initial condition of this. So that's why if it satisfy, then you may use this formula. Bn is equals to 2 over L integration from 0 to L fx sin m pi x over L dx. Okay, so we are going to use the same formula as in chapter 4 to find the coefficient for our PDE punya solution here, Bn yang ni. Okay, this Bn. Alright, so to make yourself clear about this, okay, kita ada example 6 ni lah. Okay, we have this example 6. Okay, if you use this one in this example 6, okay, bukan example 1 ni, example 5 tadi, example 5, sorry, example 5 the only difference is u at 0 is equals to 20. Tadi kan u at 0 is equals to fx, so in this case maksudnya kita punya fx is equals to 20. Okay, we want to find this solution. We know that u at t is equals to this. Now, the solution for u at t is equals to, okay, summation n equals to 1 up to infinity bn sine m pi s over l e the power of minus k m pi over l square t. So, we know u at 0 is equals to 20. Maknanya this fx kita ni sama dengan 20. So, maksudnya you are to find your coefficient bn. Bn ni kita guna je lah formula yang ni tadi. This formula where we ganti fx sama dengan 20. Okay, you replace fx equals to 20 inside the formula. So I'm not going to solve this because this is just a simple integration. Okay, 2 over L integration from 0 to L 20 sine m pi s over L dx. So bila you solve the integration, you akan dapat ni cos n pi ni adalah negative 1 power of n kan. Okay, so ni L dengan L ni boleh ganti, so you get this. So this is your bn. So dari sini kita masukkan je lah. This is our bn. Sin m pi s over L e the power of blah blah blah. So this is our complete solution of this example. Okay, the complete solution of this example if given the initial condition fx is equals to 20. Alright. Cool. So I hope so far you boleh digest, okay, what we are talking about. Alright, so we stop here for the third part of the video. In the last part of the video, we will have another 2 examples to discuss. So please stay tuned for another 2 examples in the next video, because these 2 examples are very important to all of you, especially to solve the assignment questions.